I welcome you to the crash course of eCal Academy. How are you all doing? I hope you all are okay. Okay. So today we are going to start with some properties, chemical properties of carbon compounds. So I'll be sharing my screen. Okay. So here we go. The chemical properties of carbon compounds. Children, the carbon compounds are mostly used as fuels. And because we use them as fuels, they undergo combustion reaction. Combustion reaction is the one where a substance burns in the presence of oxygen to give heat energy, light energy, carbon dioxide, and water vapor. These are the products when something burns, especially carbon compounds. When burned, they definitely give carbon dioxide or carbon monoxide, depending on the availability of oxygen. So here you can see the diagram shows the fuel is burning in the presence of oxygen, light and heat energy are being given out, and carbon dioxide is being produced. So this is the diagrammatic representation. Now there is an equation written on the top. It says carbon reacts with oxygen to give carbon dioxide, heat and light. Now this is the solid form of carbon. You can take it as coal. So coal is used as a fuel. The second equation shows CH4, that is methane or the biogas. The biogas also is used as a fuel. It burns in the presence of oxygen. The products are the same. You can see CO2, heat and light in both the cases. Water vapor is also produced. And the third equation says CH3, let me erase this, CH3, CH2OH. This is ethanol. Ethanol is also a liquid organic compound which burns and produces carbon dioxide, water vapor, heat, and light energy. So the three equations show that whether coal is in solid form or gas form or liquid form, it burns, and carbon dioxide is definitely produced. So we discussed about saturated and unsaturated compounds. Saturated, let me recall it for you. Saturated compounds are the ones which have single bond between them. When they are burnt, they produce blue flame. You can see here. They produce blue flame because they are undergoing complete combustion. Saturated hydrocarbons undergo complete combustion to give blue flame. But unsaturated hydrocarbons burn with yellow or orange flame and they give out lot of soot and smoke. This is the main difference between the combustion of saturated and unsaturated compounds. So the first one, as I told you, is the color of the flame. Now, the yellow flame will also contain soot into it. Soot is the unburnt carbon particles. Soot means the unburnt carbon particles. Now, you must have experienced when you burn a piece of paper, some black colored, very lightweight particles keep floating high up. And when you try catching them, they will leave a black coating on your palm, on your fingers. That is soot. It is because of this soot, it is a polluting flame. You can experience this in the candle flame also. On the top of the candle flame, if you put a spoon like this as shown in the diagram, after some time you will see the black deposit on the spoon. It is nothing but soot. So again, I'm repeating, soot is the unburnt carbon particles. This again, you should not be doing it at home, but you can see the black coating on the fingers when they are rolled over the flame, candle flame. This is soot. This is produced because it underwent an incomplete combustion. Incomplete combustion produces yellow flame along with soot. Incomplete combustion means the availability of oxygen is less. There are two types of combustion. Let me write here on screen. There are two types of combustion, complete and incomplete. In complete combustion, the presence of oxygen is more. Complete combustion. Here the availability of oxygen is more. Incomplete combustion. The availability of oxygen is less. So it will give you blue flame and incomplete will give you yellow flame. Here you will not have any soot in complete combustion, but incomplete combustion gives you sooty flame. This will have more calorific value. More calorific value in the flame. But incomplete combustion will have less calorific value. It means the energy content in complete combustion will be more. The energy content in incomplete combustion will be less. This is the reason that coal and wood are not considered as good fuels. They are not good fuels because they burn with incomplete combustion. They cause pollution, they produce smoke, soot, and they also have less calorific value. Instead of that, LPG, CNG, biogas, these are ideal fuels because they do not cause pollution because they undergo complete combustion. They do not produce soot and they have more calorific value, flame. So the food can be cooked faster when you are using LPG, CNG or biogas as compared to coal or wood. So this was about the complete and incomplete combustion. In this picture, the diagram is very clear. The first one is complete combustion, this one, because you can see the availability of oxygen is more. In the second one, the availability of oxygen is less, so incomplete combustion. The difference here, carbon dioxide is produced when the substance burns completely, but in incomplete combustion, it is carbon monoxide. So always complete combustion is preferred for, and that too with saturated compounds, because unsaturated compounds do not burn completely. So we have a question here, why are carbon and its compounds used as fuels? Because they burn and they produce mostly saturated compounds. They produce clean flame, no smoke. So they are preferred as fuels. The next question is, a mixture of oxygen and ethane is burnt for welding. Can you tell why a mixture of ethane and air is not used? Now, I am very sure you all know what is welding. Welding means joining metal parts. Joining metal parts. Now, to join the metal parts, you need to melt the metal. Like if you have a candle and it breaks in two pieces, you can join it by melting it at both the ends. Same way you can join the metal, but you need to melt it. To melt the metal, you need a very high temperature because the melting point of metal is very high. So you need high calorific value flame. You need high calorific value flame, and that is possible when complete combustion takes place. So now this is the background. Now you must have understood. It says ethine, which is unsaturated, and oxygen is used. So when you have this combination, you will get the flame of high calorific value. It is enough for the welding purpose. But if you take air instead of that, air contains 21% oxygen. So because of air, it will undergo incomplete combustion. It will undergo incomplete combustion. So the flame will be of less calorific value, which is not recommended for welding. It will not help you do the welding. So this is the reason over here. You can read the answer, then we'll go further. This CH triple bond CH is ethine. In the last class, we discussed this. The "-ine" suffix is the ones which have triple bond between them. Okay, now the next thing is why some substances burn with flame and others do not. Some substances burn with flame. Children, the reason behind it is the substances, the gases always burn with flame. The gases burn with flame till the last particle. But if suppose you are burning a liquid like petrol, petrol is a liquid. When you are burning it, it vaporizes and produces vapors of petrol, I would say, vapors of petrol in the gas form. So then it will also burn with flame till the last particle. But if you are burning a solid like coal, then it will burn with flame only till when there are some substances which can be gasified into that are present. When the substances get over or exhausted, the flame goes away and you simply see it glowing. You simply see it glowing. You don't see the flame in coal or wood anymore. So I repeat, if you are burning a solid substance, it will burn with flame only till the time the substances present into them are converting into gas. Till that time you will see it in flame, and after that it simply glows. So the concept is simple, but you are asked questions based on this. Now, what is coal? Coal is a fossil fuel. You must have studied in social science also. It is a fossil fuel which is produced by the dead remains of the trees. And it takes millions of years to produce coal. In this diagram, you can see the trees got buried under the earth because of natural calamities, and then under two factors, high pressure and high temperature. High pressure and high temperature converted the trees into coal. So this because the making of coal is just like fossil fuel, it is called a, I mean, just like fossils, it is also called fossil fuel. Petroleum is also formed in the same way, but the only difference is to make petroleum, marine organisms are they get buried under the earth, under the ocean floor, and with the passage of time, they convert into petroleum and natural gas. So both coal and petroleum are the fossil fuels. Now you can see the three reactions here. In all the three reactions, the substance is gaining oxygen.
Excuse me, ma'am.
The substance is gaining oxygen.
Excuse me, ma'am.
Yes.
Ma'am, what is different between volatile substance and non-volatile in
Okay,
the
good. Okay. Volatile substance is the one which is having extremely low melting point. Because the melting point is very low, it starts, sorry, I'm sorry, boiling point. Because the boiling point is very low, it starts boiling at the room temperature. A few examples we'll take, like the perfume or your deo. When you spray it on your palm, for few seconds your palm becomes wet. After that it gets dried up because the perfume got vaporized, and it was so quick, just because the boiling point was low, so actually it boiled off from your palm. So we call perfume highly volatile. It will not happen with water. If you have water on your palm, it will not vaporize that quickly, right? So volatile substances are the ones which have low boiling point. I hope I have answered your question. Okay, so let
ma'am.
us go ahead.
Excuse me. Hello.
Yes, did you say something else? Yes.
Ma'am, I have one more doubt.
Yes.
Why some substance burn with flame and others do not with flame?
Okay, okay. So let me go back to the slide again so that I can explain it to you. See, I'm erasing the contents. See, gas will only burn with flame till the last particle, till the last particle. Only gases can burn with flame. But if you take the example of petrol, petrol is a liquid, right? Now, when you start burning it, when it burns, two things happen at the same time. One is liquid petrol is converting into vapors of petrol, vapors of petrol. And because the vapor is the gas form, the vapor is the gas form, it will burn with flame. Because remember, I told you only gases burn with flame. So vapors of petrol are the gas form of petrol. It will burn with flame till the last particle, till the last particle. But if you take a solid like coal, coal has certain volatile substances into it. Coal has certain volatile. All substances present in coal are not volatile. Only some substances in coal are volatile. So when you burn coal, those volatile substances will burn with flame. When these volatile substances get over or get exhausted, then the flame goes away or puts off, and we simply see it glowing. We simply see it glowing. This is the reason that some substances burn with flame, others do not. Let me give you one more example of camphor. Shall I erase it from the screen if you have noted it down? Okay. Okay. So let me take the example of camphor. Camphor is a solid substance. If you burn it, it will burn with flame again till the last particle. Till the last particle. Because camphor is made up of 100% volatile substance. Means entirely camphor can be converted into vapors. Solid camphor can be completely converted into vapors of camphor. And because vapor is the gas form, we will see it in flame till the last particle. Is it clear now?
Yes, ma'am. Clear. Thank you, ma'am.
Okay. Great. So good, keep asking your doubts if you have any. Just a second, let me remove this box from the screen. Okay. Now, we were discussing about these three equations. In all the three equations, you can see oxygen is being added. Oxygen is being added to the reactant. And addition of addition of oxygen is called oxidation reaction. Oxidation reaction. So these three reactions are showing oxidation of carbon, of methane, of ethanol. Okay. So let us see now oxidation of some other carbon compounds. Right? This we have already studied in chapter 1, oxidation. And oxidizing agents are the ones which are responsible for the oxidation of the other substance. Okay. Now, the first example here is ethanol. This is ethanol. CH3, CH2OH. You can see this is CH3, CH2, and OH, right? Now, if we add oxygen into it, it converts to, you can see CH3, COOH. This is called ethanoic acid, right? So when oxidation of ethanol takes place, it converts to ethanoic acid. Now we cannot simply add oxygen into it, but we need to use some agents. That agent is called oxidizing agent. Let us see what are those oxidizing agents. The first oxidizing agent here is potassium dichromate. Potassium dichromate, DICHROMATE, K2Cr2O7. Now it says acidified potassium dichromate because few drops of acid are added into it to activate it. Okay. So what you are going to do is you take ethanol, which is colorless liquid. Okay, it is a colorless liquid. And you put some acidified potassium dichromate and you heat the contents. It will convert into ethanoic acid. It will smell like vinegar. So what you have done? You have done the oxidation of ethanol. There is one more oxidizing agent, this KMnO4. It is called potassium permanganate. This is called potassium permanganate. Okay. Now it is alkaline in nature because few drops of alkali are added into it. Few drops of alkali are added into it. So the same thing here, when you use alkaline potassium permanganate, it converts into ethanoic acid. So from this concept, you can be asked a question like, uh, when you add acidified potassium dichromate to a liquid X, it changes to a substance which smells like vinegar. Identify this substance X. Write down the type of reaction. So this can be asked. So here you can write any of the equation. Either you write number 1 or number 2. Right? So this is oxidation of ethanol. Now you will see some color change over here. When you are using potassium dichromate, this potassium dichromate, you will see the change from orange to green. Okay, from orange to green. But when
Excuse me, ma'am. Ma'am. Ma'am.
yes,
Ma'am, can I write C2H5OH instead of CH3 CH2OH?
yes, you can write. You can write. C2H5OH is also ethanol. It is the condensed formula of ethanol. So that is correct.
Thank you, ma'am.
Okay. Okay, right? So you can notice the change in color. So oxidation of ethanol. Now the question based on this concept, why is the conversion of ethanol to ethanoic acid an oxidation reaction? So the answer is simple, because we are adding oxygen. We are adding oxygen to ethanol. It is called oxidation reaction. Right? Now let us go to the next one. What are oxidizing agents? Oxidizing agents are the ones which are responsible for the oxidation. Like in the previous slide, we saw K2Cr2O7 or KMNO4. They were responsible. They were responsible for the oxidation of C2H5OH. They were responsible for the oxidation of this. So they are called oxidizing agents. Like a ticket agent is responsible for getting the tickets done for us, right? Similarly, oxidizing agent is responsible for oxidation. Now, some reactions which involve addition of two reactants to give one product is called addition reaction. There are two reactants like dash plus dash will give you dash. So reactants are two, but the product is only one. That is why we call them addition reaction, because the things got added. So let us see what is addition reaction. Now we know about saturated and unsaturated compounds, right? I will give you one example. Like these are two carbon atoms here, and I will add 3 hydrogen with both of them. So it makes C2H5 H6. This is saturated. Now let me draw another one. Here I am having 2 carbon atoms and 2 hydrogen atoms. This is C. Yes, so we have resumed here. Would you like to answer which one can undergo addition reaction, saturated or unsaturated? If don't get scared, even if your answer is wrong, it's okay. But give it a try. Okay, let me see. This is already full to the capacity. C2H6 is already full. Why I call it full? Because the valency of carbon is 4. So for both the carbon, the valencies are done. See, 1, 2, 3, 4. Same for the second carbon, 1, 2, 3, 4. So all the 4 valencies are done. Even, yes,
मैम C2H2O अनसैचुरेटेड कंपाउंड है कि नहीं है?
C2H4 unsaturated है.
C2H2 मैम.
Why? हाँ, C2H2 also unsaturated. C2H2 भी unsaturated है. It is also unsaturated. Okay. Okay. Now see what happens is, shall I resume or any other question? Okay, see what happens is, this here you have a double bond here, but if you can break one of the bond, like it was having a double bond, right? But if you can break one of the bond, then it is possible to create one more vacant space or place. See, earlier it was like this. It was double bond over here. I'm erasing, I'm making it again. See, it was like this. But what we have done, we break one of the bond here and we can create 2 more places here, 2 more vacant places here. So we can convert it like, the only thing is we have to break the double bond and convert it into single bond. So addition is possible in unsaturated. Addition is possible in unsaturated. We cannot add in saturated because it is already full. Right? I hope you got this concept. So let us see one addition reaction in unsaturated. You can see this is the compound unsaturated. There is a double bond here. There is a double bond here. Now, when we add hydrogen in the presence of nickel catalyst, it converts to single bond. Earlier we were having a double bond here. Now it converts to a single bond. So here we are able to add hydrogen to unsaturated compound to convert it into saturated one. Okay. So addition is possible in unsaturated. Now, this is industrial process. This is industrial process. You know what happens? They take vegetable oil, which is liquid. There are many examples like coconut oil, palm oil, mustard oil. They take any oil and add hydrogen into it in the presence of nickel catalyst. So what happens? It converts to vegetable ghee. This is solid. They do it in industries. This reaction is called catalytic hydrogenation. Catalytic hydrogenation. Okay. So when they ask you what is catalytic hydrogenation, you tell this one. It is the addition reaction where hydrogen is added to unsaturated compound to convert into saturated one. Okay, so addition reaction is also done. This is the question, what is the industrial applications? Just now as I explained you can answer the question. Hydrogenation, catalytic hydrogenation is a process where unsaturated compound is converted to saturated one in the presence of nickel as catalyst. Instead of nickel, you can have platinum or palladium also. You can either take nickel or platinum or palladium, any one of that. Okay. Now, there are certain substances given in front of you and they are asking which one will undergo addition. It means you have to find out which is unsaturated. Because as I told you, only unsaturated will undergo. So both alkenes and alkynes will undergo addition reaction. Now how to find it? In the last class, we discussed their general formula. I hope you remember it. General formula for alkane, for alkene. CnH2n. And for alkyne, CnH2n minus 2. So you need to find out now which one is unsaturated out of it. How to do? Use the general formula and get to know. Let us see. C2H6. Which formula is applicable? We have for alkanes, we have this. See. For alkanes, we have CnH2n plus 2. Now see, this is applicable. Which formula is applicable for the first one? For this one. You can tell me. Which formula out of 1, 2, and 3 is applicable for C2H6? Would you like to answer? Would you like to answer C2H6? This is 2 and this is 6. Which formula 1, 2 or 3 is applicable? Formula number 3 is applicable because if C is 2, H is 2 into 2 plus 2. C2H 4 plus 2. C2H6. So this is saturated. This is saturated. Saturated will not go on addition reaction. Now check the second one, C3H8. Which formula do you think? Will you answer? 3 and 4, okay. Okay. Let us check. 3 is this one. So 3 is good. It is this. And C2H2 is this. Very good. Very good. All right. So the question was simple. You can answer like that. Now it is asking, give a test that can be used to differentiate chemically between butter and cooking oil. See children, butter is saturated. and cooking oil is unsaturated. There is very simple test. What you can do is take 2 test tubes. Okay? In one test tube, you take cooking oil. In the other one, you take butter. Okay? Now, you put some bromine water in both of them. Bromine water. This is bromine water. Let me label it. Bromine. Bromine water is reddish brown in color. Reddish brown in color. Now one test tube, in one of the test tube, the reddish brown color will go away. It will lose the reddish brown color. In which one do you think it will lose? Any guesses? In which one it loses reddish brown color? In unsaturated, it loses color. It loses color. And no loss of color. No loss of color in saturated. Because bromine becomes the part of unsaturated. The way we added hydrogen to unsaturated in the previous slide, we can add bromine. So bromine loses its color. So this is called bromine water test. Right? Now, you can see here, this is methane. When you make it react with chlorine in the presence of sunlight, it loses one hydrogen. See, this is what has happened. This is this one. It is CH3Cl plus HCl. Now, if you do it one more time, it loses 2 hydrogen. It is this one. If you do it one more time, this is what happens. One more time, it loses 3 now. One more time, it will lose all the 4. You can see here. All the 4 hydrogen, CCl4. So these are called substitution reaction. Substitution reaction. It's just like a player who got hurt and was substituted, right? So substitution reactions are the ones where hydrogen can be removed and some other substance can take its place. Okay. So in your textbook, this equation is given. Substitution reaction. Substitution reaction can take place only in saturated ones. All right. Now this question is, explain the nature of covalent bond using the bond formation in CH3Cl. It is CH3Cl. This is hydrogen, hydrogen, hydrogen. So how will you explain it over here? You can explain that carbon has valency 4, hydrogen has valency 1, chlorine has valency 1. So carbon can share 3 electrons with 3 hydrogen, atoms. And 1 can be shared with chlorine atom. 1 electron can be shared with chlorine atom. So what you can do is 1, 2, 3, 4. This is hydrogen having its 1 valence electron. And this is chlorine with 1 valence electron. So see, first hydrogen is okay. It has 7, 1, 2, 3, 4, 5, 6, and this is the 7th one. So chlorine is okay with 8 electrons. Now make carbon happy with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this is how you can explain. Okay. The answer seems to be very long, but the explanation is simple. You should be able to draw the diagram. All right. So far we have discussed these all reactions of carbon. You can check it. These are the reactions that are done so far. Right. So in the next class, we will be discussing the chemical properties of ethanol and ethanoic acid. If you have any doubt, you can ask. If any doubt, you can ask. Okay, so I think we can wind up for the day.